So this is a video about factoring all different kinds of polynomials, and this is really going to help when we get to section 5.5 that you already know how to factor. You'll also receive a factoring flowchart to help you know which path to follow based on the number of terms that you have. And so the first thing you need to know is that when you see factor, you need to first always check and see if you have a greatest common factor or a GCF. And so when I'm looking at this polynomial here, I want to see if there's something that I can pull out of all of the terms. And so I'm looking at the coefficients. I have 8 and 2 and 4. And I know that 2 will go into each of those. So I know I'm going to be able to pull out 2. Now I'm going to look at the variable parts of it, and I see that each one has an x squared in it that I can pull out. So you want to look at the variable and pick the lowest exponent that you can pull out of all of them. So I'm going to be able to pull out 2x squared. And then I'm going to say 8x to the fourth divided by 2x squared is 4x squared. And then if I pull out 2x squared from 2x to the cube, we're just going to have minus x. And when I pull out 2x squared from 4x squared, we're just going to have plus 2. And that, I believe, is all that you can do to this polynomial. But from here, if you could do more, you would check and see if you could factor that trinomial. This one won't. But you should always check for that. And you can also check your answer by saying, is 2x squared times 4x squared 8x to the fourth? Yes. Is 2x squared times negative x negative 2x cubed? Yes. And is 2x squared times 2 plus 4x squared? And it is. So we haven't changed the value of that polynomial at all by pulling out the greatest common factor. So next, you want to check and say, how many terms do you have? Do you have 2 or 3 or 4? Now we're going to assume now that you've already pulled out your greatest common factor. And the first case we're going to look at is if you have 3 terms, you're going to see if you can factor the trinomial. And let me move this down a little bit here. So the book that we have teaches a very good way of factoring trinomials, and it takes practice, which is why this is in your factoring packet right now. But if you do this way, it gets rid of a lot of the guess and check that's involved with it. And so the first thing you want to do is you want to identify A and B and C. And so in this case, A is 5, B is 19, and C is 12. So to figure out how to factor this, you're first going to say, what is A times C? And in this case, A times C is 5 times 12, which is 60. And now we're going to say, what is B? Well, B is 19. And so what you want to do is you want to figure out what's going to multiply together to give you 60, that's going to add to give you 19, and you start guessing and checking. So when I'm thinking about 60, I can say, well, 20 times 3 is 60. But is 20 plus 3 19? No, 20 plus 3 is 23, so this is not what we need. So let's try something else, and I'm going to say 15 and 4. So 15 times 4 multiplies together to give you 60, and 15 plus 4 is 19. So that's what we want to use. So the hardest part is done. Now what you're going to do is this is what it breaks up that middle term into. So we're going to rewrite this polynomial as 5n squared. That doesn't change. But we're breaking the 19n into 15n and 4n based on what we found right here. So plus 15n plus 4n plus 12. And so we have not changed the value of that polynomial at all. All we've done is broken apart that middle term. And now we're going to do what's called factoring by grouping, meaning that we're going to put these two terms together and we're going to put these two terms together. And we're going to factor out the GCF from what I put in the red parentheses and what I put in the green parentheses. So going to the red parentheses, 5n squared plus 15n, I can, oops, that's not red. I can pull out 5n from both of those. And when I pull out 5n, I end up with n plus 3. So going to my green parentheses, I look at 4n plus 12 and I realize I can pull out 4. So I'm going to put plus 4 times n plus 3. Now if this term here were negative, you would want to pull out a negative from that GCF, as that GCF. So when you've done this, if you've done it correctly, these binomials should match. So now when we factor this, what we get is 5n plus 4. So we basically took this term plus this term. And then the other factor is simply n plus 3. And that is your final answer. So factoring trinomials, even though that's what you've done the most of, it still tends to be the most difficult for people. So practice this method on the worksheets I gave you and you will have this down. The next part of factoring is when you check for the number of terms. If there are 2 terms, the first thing you need to do is check for a difference of perfect squares. Now, what are perfect squares? Perfect squares are based on the area of a square. And so if we say that n is our side length, then we're going to say that the output is the area of the square. So our first perfect square is 1. If you have a square with a side length of 1, 1 times 1 gives you an area of 1. Next is where n is 2, you have a side length of 2, the area is 4. Where n is 3, you have an area of 9. And so this column here is all of your perfect squares. And you should know these really well up through 12 times 12, which is 144. You should recognize all of those perfect squares. But what about when there's a variable term? We can say, what if the side length is x? Well, then the perfect square would be x squared. What if the side length were x squared? Well, x squared times x squared would be x to the 4th. And what if the side length of the square were x cubed? Then the area of the square would be x to the 6th. So when you look at these variable terms and try and identify if they're perfect squares, you'll see that all of them have an even exponent. So when you have a variable term with an even exponent, it is a perfect square. So let's look at this, x squared minus 25. You ask yourself for the first term, do we have a perfect square? And yes, x squared is a perfect square, and I'm going to put little fireworks out because it's x times x. And 25, do we have a perfect square? Yes, we have a perfect square because 5 times 5 gives you 25. And so we made little fireworks to show what the square roots were. So now to factor it, you double bubble, and you put plus or minus, and then you just fill in those square roots. So we have that x, and then we have 5 and 5. And you can check your answer by foiling this or multiplying it out. And what happens when you foil this or multiply it out, that middle term cancels out, which is why you only have 2 terms. And just to show the check, we have x times x is x squared. X times negative 5 is 5x. 5 times x is plus 5x. And 5 times negative 5 is minus 25. So these 2 middle terms cancel out. So that's how you check your answer on these. So let's go on to the next one, and I'm going to erase that to make room to make our fireworks on this next one. So 4x squared minus 121y squared. So you ask yourself on the first term, do we have a perfect square? And we'd say, yes, we have a perfect square because 4x squared is 2x and 2x. And then 121y squared, do we have a perfect square? Yes, we do, because that's going to be 11y times 11y. So now we have a difference of perfect squares, so we're going to double bubble, put plus or minus, and we're going to put in our 2x and 2x and 11y and 11y. Now what about 9x squared plus 4? We do have a perfect square for the first term, and we do have a perfect square for the second term, but it's not a difference. So this one will not factor, or we would call that prime. All right, the other thing you want to check for when you have 2 terms and it's not a difference of perfect squares is you check to see if you have a sum or difference of perfect cubes, and we're going to look at how you factor that. Now we need to ask ourselves, what is a perfect cube? And a perfect cube is basically if you have a cube and you look at the side length, if that side length is 1, what's the volume of that cube? So we'll say n is the side length, and the perfect cube is basically the volume of that cube. So 1 times 1 times 1 is 1. What about 2? Well, 2 cubed is 2 times 2 times 2, or 8. And 3, the volume of that cube would be 3 times 3 times 3, which is 27. And 4 would be 4 times 4 times 4, or 64. And you should be familiar with these. 5 times 5 times 5 is 125, up through 6. These get big quickly, and 6 times 6 times 6 is 216. You should recognize those perfect cubes. Now, what about if you have a variable? And how do you know that the variable term is a perfect cube? Well, if you have x as the side length, then the volume would be x cubed. If you have x squared as a side length, you take x squared times x squared times x squared, and you get x to the 6th. If you have x cubed as a side length, you take x cubed times x cubed